This question actually comes under the concept of Egyptian fractions, and that's the idea that the Egyptians showed you could write any fraction, I believe, as the sum of unit fractions where the numerator is 1. It might not be possible to write it just as 2, you might need like more than 2, but I think they found algorithms for how to do that. So if you're interested in this question, if you enjoyed this question, you might be interested and follow that up. If you're not interested in it, then I'm just going to kind of show you how you could go about it. No like algorithms as such, just playing with numbers essentially. Because I want to look at the example they've given us, a half equals a third plus a sixth. How could they possibly have figured that out? Well, I think the way to go about this is to write some equivalent fractions down for a half. So 2 over 4 would work, and then you could write 2 over 4 as 1 over 4 plus 1 over 4. But they've got to be different. So if I then write another one down, 3 over 6, then I see that I can write that as 1 over 6 plus 2 over 6, if I understand adding fractions, and that's going to give me my solution. So if you weren't sure what to do at the start of this video, maybe that gives you enough of a a starting point to do the rest. Okay, I'm going to keep going through them. So a quarter I could write as 2 over 8. That's not going to help because again, that would be 1 over 8 plus 1 over 8, no good. What about if I change it to 3 over 12? So I've times top and bottom by 3, because then I can write it as 1 over 12 plus 2 over 12, and I'm done, because you can see where I'm going with this. As long as the numerator goes into the denominator and cancels down, then I'm sorted. So this is going to be 1 over 12, and then 2 over 12 is going to become 1/6, and I found my first answer. All right, next one. Okay, 2 over 10 is not going to work, so let's jump to 3 over 15. That'll be 1 over 15 plus 2 over 15. That's actually not going to help there. Bit of a trickier one. So let's do it. Let's keep going. Times top and bottom by 4, the original fraction, 4 over 20. Well, I could have 1 over 20 plus 3 over 20. That's not going to work. 2 over 20 plus 2 over 20, that's the same thing. So no, I don't think that's going to work either. All right, 5 over 25. Just keep going. Yeah, that's not gonna, 1 over 25 plus 4 over 25, it's not gonna cancel down, so I've got to keep going. 6 over 30. I reckon this might work, because then I'll have 1 over 30 plus 5 over 30, and yes, we're there. Okay, it took a bit longer, but we got there. 5s into 30 goes 6, so it's going to be 1/30 plus 1/6. Second one, done. Okay, last one. I don't know, I've got a feeling this one's going to be the trickiest one, but hopefully along similar lines. Let's give it a shot. So 2 over 12 is not going to work. What about 3 over 18? Okay, actually, that seems to be pretty good. Maybe that 1/5 one was the trickiest, because that's going to be 1 over 18 plus 2 over 18. And so that's going to be 1 over 18 plus 1 over 9. And we've done our other set of fractions. You might be interested in keep going, how could you do it for other ones? I suppose this isn't quite Egyptian fractions, because we've already got a unit fraction. The Egyptians were more focused on things like, if it wasn't a unit fraction to start with, what about 3 over 7, for example? But, the concept is there, and I've given a way of doing this question. Hope you're happy with it.